Hi, are you interested to learn about how to develop apps for multiple platforms with Xamarin Forms? Me and Johan Karlsson has written a book about it. The name is Xamarin Forms Project and published by Pact. First, you will get an introduction to Xamarin and how to set up and develop a machine. When you are ready to start develop, we will guide you through 7 projects. It will start with a project where you will learn all the basics of Xamarin Forms, and we will continue with more advanced stuff. For example, how to access platform-specific features, location tracking in the background, real-time communication with Signal R, augmented reality, and machine learning. Hi, and welcome to App in the Cloud, the 3rd episode. And today I have a guest. We are at Swetugg in Stockholm, a community-driven conference. And I'm sitting here with Glenn F. Henriksen.
That's
welcome.
Correct. Thank you. Thank you very much.
We will talk about event-based serverless computing today. But first, I will give you a chance to introduce yourself for the listeners.
Okay, yeah. I'm Glenn. I am working as a consultant currently in Knowit in Norway, town of Stavanger on the west coast. I've been trading code for food for about 20-ish years, almost. And during that time, I've made a lot of mistakes. And mistakes are something we learn from, so that's why I'm doing this talk, because I did a talk about this here at Swetugg. Yeah. And I found that events have solved quite a few of the problems I've had throughout the years. So that's my background. Yeah, you could probably say a lot more about me, but it's probably not nice. So
I was listened to you talking. I find it very interesting, and I saw you on Tech Days.
Yeah, I did the same talk on Tech Days.
Yeah, and that's what made me interesting to invite you to the podcast. So
thank you for inviting me. That was a pleasure.
Okay, so the topic for today is event-based serverless. Can you describe the basic of event-based architecture?
Sure. Let's start with the problem it solves. So the problem it solves is that when we start building our applications, we try to build a foundation and we build something upon that and we build something upon that, and our application grows. And it is not only impossible, but it's not even desirable to anticipate all the growth that application can have beforehand, because we can't, because things change and we have to adapt, and otherwise we'd be doing waterfall, and we decided 20 years ago we're not doing that. So as we change an application, we introduce complexity. As it grows, more and more pieces, they talk to each other, they connect to each other, and we have what's called often high coupling, which means we have a lot of connections between different parts of an application, and we have very often low cohesion. Cohesion is a term we use to describe when something belongs together, it should be together. So we have low cohesion, means things are spread all over the place, and we have high couplings in our application because we introduce a little bit here, a little bit there, and a little bit there, and we don't always think of the system as a whole. So we try to do different things to reduce the complexity, but usually complexity grows exponentially, so we can't do enough things. And that's how people get what we call the monolith, the huge application where everyone is afraid to change anything. And even the slightest introduction of new feature risk tearing down a whole other part of the application. And it's not only just the application and code. As an application grows, it is also different teams, it's different people working on different things, and these problems just go all over the place. So people start splitting up their applications, and they have this thing does this, and this thing does that, and we split them up in different teams, and this works very nicely for getting the cohesion under control. Now, things that belong together go together in that app, and that app, and that app, and the problem is still communicating. So when the applications talk to each other, they often do that with a HTTP or REST-like interface, and that will hurt.
Yeah, I've been in a project where we use transactions over VCF services between
God, no. Oh,
that was a mess.
That is a mess, because what you have done there is you have split the application up, you fixed the cohesion problem, but you haven't fixed the coupling problem. So the different parts have still a lot of hard couplings, and in the case of transactional VCF, that's hard couplings. That's hard mode. That's playing the game on expert mode. And events can be a solution to this problem, because what you people have done then is that they've built a distributed monolith, which is even worse than the monolith, because then you have the same problems you had before, you just spread them more out. So events are things that happened in one application, and we can notify another application about this, and they don't have to be directly connected. The good part about this is that in my publisher, the service that publishes an event says, this thing just happened, or I would like this thing to happen. It doesn't need to know who or what is listening to that event or subscribing to that event or that message. It can just say, this thing happened, or I want this thing to happen. I want to put 500 kroners in your account. I want to book a flight from A to B. I want to so and so. And how that problem is solved, or how that task is carried out, or if someone even cares, it's no longer a concern. So we reduce the couplings to sending that event or message to a message service. The other service can listen to those kinds of events. It will subscribe and pick up, so, oh, this thing just happened, let's work with that, let's do what that means, and so on. This solves a problem with the traditional REST, HTTP, WCF, or other horrible things like .NET remoting, if anyone ever used that. If you do, I'm sorry. Where you had hard couplings and you were hard dependent on the other service. If that was gone, you had a major problem, and you multiply that by the number of services you should talk to. Now we only connect to the messaging service, and that's who we care about. The good thing is I can now add multiple services listening to those events without changing the implementation or even touching the code or deployment or anything of the other services in my system. This is the open-close principle in Solid, and I can change my system without changing my system. It is, I can add functionality without changing my existing code. If I want to react to something new, something I didn't do something else with a message that I haven't done before, I can just introduce a new service, subscribe to the event, and I don't have to change any of the other services or publishers or subscribers or anything. So events are pieces of information being sent from a service or an application, usually to a messaging service, and subscribed to by one or other or more parties. I mentioned both events and messages, and those are two different things. So we use those terms to mean different things. So messages are pieces of data that have value. They often have an intrinsic value of their own. They mean something. It would be a shame if that was lost. It has information on what should be done. It is also an expectation on the publisher's behalf that when I send this message, things will happen. If I send you a message saying transfer this amount of money from this account to this account, the sender expects that to happen. If it sends a message saying that this order should be created with so-and-so order lines, it has an expectation of that being carried out and the order actually being created.
But if you're sending a message, for example, if you want to do a transaction, how will the publisher get notified that it has happened? Because
so what you can do then so this is now asynchronous. So in HTTP and REST and all those are synchronous. I send a request or a command, and I wait for a response, and I get a response back. There's a 200 OK. I know everything went fine. In an asynchronous world, I send a message or an event to the message service. I get a 200 OK back saying, we received your message. You're good. I got this. but I don't know what happened to that message. I don't know if that was carried out now or later, or if it broke or anything. So what you can do is you can set up a return path. So in the first message, you say, carry out this task, book this ticket, transfer this money, order this thing. And when you're done with that, send me a return message in this place. So I set up both services of both publishers and subscriber. I publish a message, and at the same time, I subscribe to the return message. So the subscriber will receive the message, do the task, and then send it back again.
Yeah, and I guess the return message could be of a different type. It must not be it could be an SMS to the user, for example.
This is what happens when, many years ago, HP tried to compete with the iPad. So HP made a little tablet computer that, compared to the iPad, sucked. So nobody bought it. And then Amazon put it on sale for $99. And people went insane. They bought it, they went on, ordered online, and everybody got feedback in the web UI that, yes, your order was received. And then even a few hours later, got an email back saying, sorry, it was sold out. So this is what happens when you can relay the confirmation in a different channel, like you say. So I make an order of something. The system will tell you your order has been received. That doesn't mean it's been approved or processed or whatever. There's lots of things that happen when you make an order of something, and any one of those things can fail. And in this case, it failed because they had 1,000 units and 10,000 people wanted to buy them. So eventually it comes down to a place where they have to pick one and one, because they have to, I'll take one out of stock, one out of stock, one out of stock, one until I'm down to zero, and then we're out. And then everyone who's left just gets an email saying, sorry, we're sold out. So you can have the return in a different channel to the user, but you can also have the return in a different channel or on a different message to the actual application. So the application can know, that thing is now done, I can move on.
Yeah, in that case, I think it could have been better that the message would be returned to the application, in this case, the Amazon website, and the user probably have got an answer faster that this is out of stock. Or
maybe, but it can also be that this depends on different systems that work at different speed.
Yeah,
so
of course,
the Amazon website and it was hammered by this because they went on sale and people just went wild. Everybody flocked to the web page. And of course, the backend system, like I said, some got the reply back hours later. Because when you have a system on web that takes orders and deals with physical stuff, you can have as many web servers on your front end as you want. You can have 1,000 web servers handling the front end, handling the load. But eventually it comes down to one system picking one order at a time and checking, is this in stock? Yes or no? I'm going to give that one to him, and I'm going to take one down from the stock. You can't have people pulling things out of stock, out of the warehouse in parallel, because then you'll have two people taking the last item, and that won't work. So it all narrows down to a bottleneck of a system that will take process one order at a time and a single order at a time. And you can't have people waiting on the website for 2 hours. You can make, if that was an occurrence that would happen often, you could make checks saying that, okay, we have 1,000 units in stock, we have 3,000 people who are in the queue to order one, you're not going to get one. But that's an odd case, and Amazon or any website shouldn't base their programming on such edge cases. So what happens is it goes in the queue, and 2 hours later they get an email, sorry, it's sold out. Of course, it was a shitty experience for those people, but it's an edge case. But in other systems, you want the application to get notified eventually, and having return messages can help that. Now, I also mentioned the word events. And events are different from messages, as in events don't have an expectation of something being done. Events are more like a notification of a fact. This thing has happened. I did this. It's more past tense. Like a message is more like the future tense, like I would like this to happen. Please make this happen. while event is often more past tense, saying this happened, this just happened, customer was created, order was created, somebody visited this page, and so on. Or it can be a fact in the moment, saying the temperature now is 20 degrees. The temperature now is still 20 degrees. It's now 20.1, and so on. And that is also the difference between two different types of events, where one is data stream events, which you would get from a temperature meter. It would respond every so and so often. It would finish off an event saying the temperature is this, the temperature is this, the temperature is this. And each individual measurement is not as interesting. You're often more interested in either the latest value or the trend of values. I'm interested in the change of temperature. How fast does it change? How fast does it go? For instance, if the temperature in my house went from 20 degrees to 70 degrees, something's probably wrong. I would like to know that. If the CO2 levels, I worked in an office once where all the meeting rooms had CO2 meters, and if the CO2 level in the room went above a certain level, it would increase the ventilation. So we never got that stuffy meeting room feeling, because it would increase the amount of air coming into the room if you had more people in the room. Well, other events are more of the type, this happened, there's a fact that just happened. The order created, it's more, they have a value on their own, but again, as events, they don't have no expectations of something happening, if that makes sense.
Yeah, I think it's a good explanation between event and messages.
Yeah.
And
so the difference is, to summarize, difference is in the intent of the publisher. The publisher has an expectation of something to happen, while the event is based there to inform that this thing has happened. It's up to the recipient if he wants to do something with this or not.
And I think if you're talking about events, we maybe have more subscribers. On message, we maybe have one subscriber more often. Or
yeah, that will often be the case. You can have subscribers to, you can have multiple subscribers to message as well. But in many cases, you will have one that treats it as a message, and the others will treat it as an event. And a message will often have an event following it. You'll have a message of create user or create order, which will be followed by an event order created, and then services will subscribe to that event.
Yeah,
so that is also true that message will have often fewer subscribers than events.
Yeah, okay, that makes sense. If we're talking about what services, for example, in Azure, you're talk about much focus on Azure. So
yeah, so Azure is my thing. That's where my people's at. So in Azure we have some what's called messaging services, which you have the brotherhood of three, where you have the Azure ServiceBus, which is the father of all messaging services in Azure. You have EventHub and you have EventGrid, and they all serve different use cases, and there's less overlap between these than you should think. ServiceBus is the Swiss Army knife of the Azure messaging platform. It is both EventGrid and EventHub are based on ServiceBus originally, but they evolved into different things. And the ServiceBus is used for transactional messaging, where you have need for transactions. You have often between several systems, through firewalls. Very good at integrating on-premises systems and cloud systems. While EventGrid is more focused on the business activity events, where they stand on their own, they're not in a stream context. There's an assumption that there may be a large number of different events in different contexts and from different applications. So subscribers need a way to filter what they take in. And there's mechanisms for that in EventGrid to say, okay, I want to subscribe to messages of this type, but only if so-and-so and so. Incoming events can be handled in parallel as an assumption as well. And also, EventGrid will push messages to subscribers. ServiceBus requires that you have listeners that connect up and actively listen for events that have an ongoing connection.
Okay, I know the ServiceBus guarantee that all subscribers will get all messages as well, if
Yes.
the timeout note has expired.
Yeah. So
something like that.
EventGrid also has a delivery guarantee
Okay.
of sorts, as in if you register a subscription with EventGrid, it will attempt to deliver. If it is unable to deliver, it will retry. It will have an exponential backup. It will have a longer and longer period between each retry. And after 24 hours, your message will go in a dead letter queue. So it will say, okay, I haven't been able to deliver this for 24 hours. I'm going to give up, but I'm going to put it here so that you can keep track of this. So the message isn't lost. But you have to look, okay, why can't this message be delivered? Maybe you had a longer than 24-hour outage. Then you have to basically find a way to pick up your events and replay them back in, which is entirely possible. And you can also have events from your dead letter storage to go to EventHub, so you can get events of your events not being delivered, which hopefully those will be delivered. But ServiceBus has more mechanisms around this, more mechanism of transaction and routing of messages. You can do more advanced stuff with it, basically. EventHub is used for the streaming data. EventHub is created to ingest huge amounts of data in a continuous stream. Like, this happened, here's what it is, here's what it is, here's what it is. It can be events. It can be events from physical sensors. It can be like temperature. It can be events from metrics on a web page, number of visits, things that happened. This was clicked, this was clicked, this was clicked, this was clicked. And you're not interested in each individual event. You're interested in looking at the stream of events and looking at that over time. So EventHub is often connected to, for instance, stream analytics, where you can do what's called temporal queries, where you can query data over time. Like, pick all the sensors where the value has increased by more than 5 in the past 10 minutes, for instance. Or pick all the items in a continuous stream, all the sensor which has a value that is higher than this in the last 2 minutes. Or you can do arithmetic. You can say, okay, we had a system where we put measurements from electrical meters in houses. They would push measurement like every 10 seconds. And we would put those into EventHub, and we have stream analytics that would take, for the last hour, as of the top of the hour until now, sum up, group by meter ID, and summarize the consumption. And then output that as another stream.
Okay, but stream analytics, that's more for analyzing the stream.
That's for doing calculations on the stream.
But it will not store the data, so you can use it in another.
It will do calculations on the stream, and it will output either a new stream. For instance, we had then got a stream of aggregated data. So we got a bunch of measurements in saying, in the past 10 seconds, I've used this amount of power. We would use stream analytics to calculate and aggregate this, saying, okay, for the past, so now it's 10 past. So for the past 10 minutes, sum up all the power readings you had for the past 10 minutes, group them by meter ID, and then create a new stream saying that for this meter ID, the consumption for the past hour is now this. And that stream again can be processed and handled or stored and whatever.
But an EventHub can have multiple subscribers, or how will that work if compared to EventGrid, for example, where you can have...
So EventHub can have multiple subscribers. It has the concept of what's called consumption groups. So each consumption group, EventHub is very good at keeping track of how far you've gotten. So how many of the events have been delivered to you. So if you have one subscriber reading from one consumption group, you get your copy of all the events. If you have another subscriber reading from another consumption group, it gets its own copy. So they'll both get all the events. And we can parallelize this, we can put this in parallel, where we can have two subscribers subscribing to the same consumption group, and they will get approximately half the events each. So they can handle the load in parallel instead of having a single thing handling. So we have multiple subscribers to the same consumption group sharing the load, if that is okay. And then you can have another place where you have another set of subscribers subscribing to the same events, but a different consumption group, which gives them their own copy of the events, which they share among them. So that's how you can use EventHub to ingest all these events in one place, and then you can pull them out afterwards, and you can spread the load on multiple subscribers, taking these events, processing them, and do whatever they want with them. While EventGrid doesn't have the same concept of sharing the load, except it will just push it. So if you have, EventHub, you have to subscribe to messages, while in EventGrid, you will get the messages pushed to you. So if you have a webhook, for instance, or a web API interface, you can have EventGrid push the message to your web interface, it is your job to make sure that scales. Now, this works very well in a serverless fashion, where you can have, in practice, infinite scale, and you don't have to worry about this. You can just have events pushed, and they're handled as they come in. There is an expectation that EventHub has a higher rate of events, while EventGrid has a lower rate of events, but it still scales to the skies, so it's not really a big issue.
Okay, so what we can say, if we have a sensor, for example, that are sending data, we will use an EventHub for handling the stream of data from the sensors.
So if you have a stream of events, like a time-based series of events, then it's EventHub. If you have business activity events, as in customer created, order created, things that happen not that often, for instance, a tracker on a shipping container notifying where it is, you can use EventGrid for those things. You would use EventGrid for those things, while you would use ServiceBus normally for messages. So that's the overlap of those three things. So I can give you some examples of different things we did with different items. So we had, I worked on a smart home thing, and I told you we had the power meters reading into EventHub, which was then processed, while on EventGrid, we would have events happening with the electrical equipment in your house, as in, was the thermostat adjusted? Was this switch turn on or off? Did the water heater kick in now or not? So those were events that happened, and we're interested in the actual event happening and not the stream of events. We're not interested in the trend lines of you turning your switch on and off. We're interested in knowing you turned your light on, you turned your light off. You set the thermostat to 20 degrees, you set the thermostat to 22 degrees. So those events were picked up and put into EventGrid. And where we could have multiple subscribers to these, we'd have one function that would pick it up and update a cloud state item. So we'd have what we'd like to call a digital twin, because that's a hyped up fancy word these days. But we'd have a state of your house in the cloud, saying which switches were on, which switches were off, and what's the temperature. Is your water heater on? Is your water heater off? We'd have one service that would pick up the event, subscribe to the event, and store it in the data lake for later analysis, because we want to make a smart home. As many smart homes today are really dumb, because the smart part of the smart home is that you can have a light switch on your phone instead of your wall.
But it's a smartphone.
But it's a smartphone.
Then you have a smart home.
I used to think there was a really low bar for calling things smart, but then politics happened for the past few years, and maybe the bar's not so low after all. But we wanted, in this project, part of it was making a smarter smart home, and we wanted to use machine learning and AI to analyze the use of your home and adjust the power consumption and spread the power consumption out throughout the day instead of having these peaks. And so some data would be stored in a data lake where we could use it for statistical analysis. Another subscription would go to an EventHub that was being fed into another system, which was being delivered by a third party that had an AI model and would take the data and generate suggestions of power consumptions in that particular house, saying that you're switch on these things, your power consumption is climbing. We're going to turn off your water heater for 15 minutes to make sure we don't peak as much. Or we're going to turn off your electric car charger for 15 minutes to make sure that we stay below a certain level.
Okay, that's cool.
And we could also do events back, saying that if someone went on your smartphone app and they pressed the button to turn on some lights or start the car charging or whatever, there would be an event sent saying, okay, start charging that car, and it would be picked up. So we in that case, we used EventGrid also for a kind of a message, but it worked really well with that.
You also talked about serverless and how serverless could be part of this event.
So the cool thing about EventGrid is that how it pushes messages. And EventGrid has a lot of built-in bindings or things or connectors that it can connect to. And one of the nice ones of those are webhooks, which fit really nicely in with Azure Functions. So you can set up an Azure function and you can connect it to an EventGrid topic. So we call those, when you have a thing that you publish to and subscribe to, we call those topics. So you can set up a function to subscribe to a topic, and that works really well with this model because these events, they don't come in all the time. They come in a little bit here, a little bit there, every now and again. There's a little bit of rush when everybody comes home and turns on the light switch and everything like that. Or when orders are created, you don't get a continuous stream of orders being created unless you're like Amazon. These things happen every now and again. And so when these events are pushed into a serverless platform, and serverless is a loaded term, and some of your listeners might look, I hate serverless.
So that you have a lot of examples.
You have all of these like, I hate the term serverless, and you have these people going, well, there is a server there somewhere. It's like they discovered this deep secret that nobody else have realized. Like, yes, I know there's a server. I don't think my function is running on a toaster somewhere, but serverless means not having to care about the servers. Like I said, servers are a problem I want someone else to care deeply about. There's a lot of work involved in maintaining a server, even just as you do in Azure, where you have like a web app service plan where you set a size and basically forget about it.
Yeah.
But even that choice, like, is it big enough? What happens if I get a lot? What happens if am I paying too much? Am I paying too little? With serverless, you can say, okay, I don't want to care about that. I have zero interest in thinking about the problem of am I paying too much or too little. I just want my code to run, man. So serverless means taking a function. So Azure Functions is Microsoft Function as a Service platform, which is serverless, where I don't have to. They have a serverless option. They have a server option as well, but you're going to have functions running on what's called the consumption plan. And running on the consumption plan, you don't care about the server. You pay for the gigabyte seconds, which is a unit most people never heard of, but it's a mixture of how much memory a function uses and how long it executes for. And this works really well in connection with EventGrid and a push-based system, because when something happens, can be pushed to a function. The function will fire up, do its work, then go away, and you only pay for that little time where the function was actually doing its work. And unless you have events coming in all the time, that works out really nicely financially. And also, it's a nice programming model where I don't have to care about a lot of infrastructure. I don't have to care about something that has to run all the time. I don't need to have a job running continuously, being subscribed to something. I don't have to write code to set it up. With functions who also have what's called triggers, I can, through configuration, say that this function is triggered by an event of this type on this topic. And that's all I have to do. And when that event happens, my function fires and I get a parameter that is filled with the data from that event. And there's no infrastructure code that I have to write here. I just configure this up through either the config file or through the parameter attributes in my Azure function. So it saves me from writing code, and the code I don't have to write has the fewest bugs. So that's nice. And it's really easy way to get up and running with just hooking up an integration. And that's where I think the functions and the serverless have a good story, is with the integrations part. I like to call them cloud glue. And the example I used in my talk is like when you're building a model airplane, you're gluing parts together, and the glue is important. It won't hold without it, but it's not the most important part of a model airplane. Nobody looked at a model airplane and said, wow, you used awesome glue in this one. But it glues things together and said, okay, I have this thing happening here. I have this thing happening that I would like to happen over there. I'll put in a function. I'll glue these two together. Now, of course, when you glue things together, you can make a mess. And you can easily do that with functions as well. You can have suddenly your business logic is spread out all over the place. There's a little bit here in that function, a little bit here in that function. How do we keep track of all of this? Who talks to whom, and so on and so forth. And these are easier problems to solve than the problems we had with the monolith application, because they're smaller and more contained, and the connections are more explicit, and they can also be discovered through code. And we're going to use tools like Application Insight, will give you a map of your application, where you can track messages going from service to service to service, provided you add a correlation ID, which is a field in all your requests that will be part of the request, and you log it as a correlation ID, and it's the same field and the same value in all your different functions. You can track the path of your message throughout your different functions. So monitoring is essential when you're splitting things up.
Okay, because when I talk to customers and colleagues about Azure Function, I think the biggest thing they worry about is how to manage them, and also about cold start times and things like that.
So the cold start thing is interesting. So cold starts is when since your function is not running all the time, it means it will be shut down, which means every now and again it will need to be fired up again, and that takes a little bit of time. It has to spin up a small VM, or it has a VM almost spun up, and it will have to dump your function into it, fire it up, run it, JIT it, compile it, and do whatever it needs to do. Same thing you do if you're making an ASP.NET web page and you compile it, and the first hit always takes a little bit of time. Yeah. It has to load up. That's called a cold start. So functions, all functions as a service has this problem with cold starts. Amazon has it, Google has it, Microsoft has it. The problem manifests in different ways on the different platforms. Some have cold starts often, but not that many of them. Some have cold starts in discrete points in time. So in Azure, if a function is not used for 20 minutes, it will be unloaded. As long as you use it every 20 minutes, it will stay warm. And also, if your function automatically scales, because you're on the consumption plan, then the first request of the new instance, the parallel instance, will also have a cold start.
Okay. But when we're talking about scaling, if you have a app service plan and that one needs to scale up to another instance, I guess you also have a cold start in that case.
That would also be a cold start. And that has, you can set auto scale for application instances, but that's slower. It has to have a certain value of CPU use for so and so long, so it responds slower to automatic scaling. Consumption plan responds almost instantly to automatic scaling. The cold start problem is not a problem unless you have a user at the other end sitting and waiting for it. So that's why maybe you don't want to use functions as the backend for your web application, because every now and again, if it's not often used, you will have a little waiting period. Oh, this is the first time someone hit that API, and then we have to wait for cold start, and then there it goes. And people have found creative ways to come around this. I saw one version where they would open a form to change something, and the JavaScript code in the client would call basically a ping method on the function app to warm it up while you were filling out the form, so that when you pressed send and it would go, the data would go to the function app, it was already warmed up from 1 minute ago.
Okay, I have used time triggers to keep it warm because
Yeah,
it's so cheap to run a function. So
Yeah.
I can run it for every 5 minutes, for example.
So that's another trick where you have two functions in the same function app, and one of them is a time trigger that just runs every 5 minutes and just does nothing, but it keeps the function warm. So, but if you have a service-to-service scenario, if you have to wait every now and again, you have to wait 2 seconds for the trigger. It doesn't matter. Nobody cares. So in many cases, the cold start is not a problem. It's a technical thing that we like to, and we like to indulge ourselves in fixing technical things, but in many cases, it has zero business impact. So for instance, if someone turns on a light switch at home, if it takes 2 seconds for that to register in our state in the cloud and stored in the data lake and shipped to the AI engine, it doesn't matter. It's well within our parameters. So sometimes the cold start is not a problem. Now, you can take Azure Functions and run it on an app service plan like you would do with Azure Web Pages. Now it's no longer serverless. You have a server there and you have to decide how it scales, but that is an always-on scenario. The cold start problem is basically gone, and you manage your own size or own scaling. And you also have a fixed price with a consumption-based pricing. You don't have a fixed price, but you also don't have a max price. So in theory, it could rack up a significant bill if someone decided to DDoS your functions and were able to do that. There's ways of getting around this, just got to be careful with it. In most cases, you will see significant savings on using the consumption plan. I don't know if you know the Have I Been Pwned site by Troy Hunt.
No.
He's put out some great posts on his cost of running that on Azure Functions, and he's been clever about it. He's done a few other tricks in Azure, but the cost of running Have I Been Pwned, which has millions of hits and everything, is like under $10 a week.
Okay, that's nothing.
It's literally nothing.
But I have heard a story. I think it was Catherine in some podcast talked about that Microsoft had customers that had called the Microsoft customer service and asked them why the invoices are so low.
Yeah,
after they started using.
I'm not
functions.
surprised. I'm not surprised at all. So functions are incredibly cheap. Once you start using them, they are incredibly cheap. So that's one of the advantages for serverless. One, I don't have to care about it, and two, I don't have to pay for capacity that I don't use. With the consumption plan, I only pay for the exact amount of time it takes to run my function. And if that is less than 100% of the time, there's probably money to be saved in there. But for me, the biggest advantage is cost is one thing, but that's often not the biggest advantage is it makes me react faster to things. I can faster push some business code, faster connect it, faster hook up these two things. It makes me more agile, actually.
Yeah, every time I will write something today, I always starting with functions because I don't have to write all the boilerplate code. If I want authentication, Azure can handle all of that for me. And
yeah, you get a lot of things out of the box, and the code you write is normal C# that you would have written anyway. So if you decide, well, okay, I've gotten to this point where functions are no longer viable for me, it's no longer an option, you just take the exact code you wrote and put it in a bigger app and make all the plumbing around it that you didn't have to make before, and then you migrate that way. So there's all your investments going into functions and starting with functions can immediately be reused if you want to do something different with it. So yeah, I think especially if you do integrations between systems, like systems talk to systems and message between systems, start with functions. Totally.
Okay. Do you have anything more you want to talk about in this topic, or?
I don't know. Do you have time?
I have time, so it's no problem for me. So
well, I can also mention a variant which a lot of developers don't think about when they're doing programming, and that's Azure Logic Apps, which, when you look at it, is basically programming through flowcharts. And all the programmers go, that's not programming. And yes, it's not. It's organizing. It's organizing services together, which it can be extremely effective to do. Because what Logic Apps does, it basically takes a bunch of web APIs or REST interfaces or HTTP services, and it gives you a way to read them or even trigger from them, take the data and do some manipulations to it, extract data, make some yes or no, if then else, and loops around this data in a very simple flowchart fashion. It's always hard to draw on a podcast, but imagine I'm drawing a flowchart. And it has a bunch of built-in connectors to a whole lot of SaaS services like Salesforce, Dynamics, on-premise enterprise software like SAP, a bunch of databases, file systems, all the Office 365 services. And you can use that to really, really quickly set up a job or some logic that takes an input, does something with it, makes things happen around, and it can connect to functions. So if you want to make some code, when this happens, I want a piece of code to run, just plug in a function and make that happen. So I used it to make a really simple thing where we wanted to get weather forecast data. We wanted to get weather forecast data on a periodic basis, So we used this. One example where I used Logic Apps really effectively was we had a weather forecast we needed to pull down because we wanted to make predictions on what the weather would be because we had solar panels and we wanted to predict the amount of power they would produce in the next 24 hours. And these weather forecasts were updated every 4 hours. So every 4 hours, I made a Logic app that started with a time trigger every 4 hours and had one task was download this file because it was just a JSON thing. You would get a simple URI, and it's a download file, give it URI, parse JSON, which is another task, which say you give it a JSON schema, and you can do that by example, like pasting a JSON file, and it says you get it back. So okay, take this field and this field and this field, and then store that in the database. Put this in the database, so and so. Or I could trigger a function with it. We did that eventually. All kinds of stuff you could do. And setting that up, making a job that runs every 4 hours, downloads a file, parses the JSON, stores the data in a database. I set that up running in a production environment in like 10 minutes.
Okay, that sounds very powerful.
So for these simple things that there's no value to the customer in making a downloader, making a JSON parser, doing all these things. It doesn't offer value, and it's just busy work, right? It's the equivalent of the guy running around the hall with a clipboard trying to look busy. What did you do? I made a little thing, the job that will download a file, do this, do that. It'll spend a few hours on that. It's like, okay, it sounds great, but it's just waste of time. So you can do some of these tasks can be do really effectively with just a Logic app. And if I have some data, I want to put that into Salesforce, like customer created something, add that person to a mailing list in Salesforce. You can do that with Logic app in, again, like 10 minutes if you want to. So for those kinds of things, Logic apps are also really powerful, and they're serverless. They run on a consumption basis. You pay by execution. They're more expensive than functions, but still they're pretty cheap.
Okay. I think they want the room we are recording in now.
Yeah,
so-
they've come knocking a couple of times. So if anyone wants to ask me about anything with Azure or especially event-based computing, I'll try to answer to the best of my ability. You can find me on best way is find me on Twitter at Henriksen, Henriksen. Ping me there, and I'll see what I can do.
Yeah, we will add that to the show notes as well, so it will be easy to find for listeners. Thank you very much for joining me.
Thank you for having me. That was awesome. Thank you.